All right, everybody, let's wrap up our discussion of t-tests by covering the third and final version of the t-test called the paired samples t-test. So let's get into the paired samples t-test by talking about the what and the when. So the paired samples t-test, it's also called the dependent samples t-test, is similar to the independent samples t-test. You're looking for a difference between two related samples, okay? The independent samples t-test, you have two groups, but they're unrelated. With the paired samples t-test, you have two groups, but they are related. So think of paired as indicating related, right? They are paired together. Now, there are different scenarios when you would use a paired samples t-test. The most common scenario you come across is when you have one group of people, one sample, and you have studied them at two different times. And you get a mean from time one and a mean from time two, and then you want to compare the means of those times to each other. That's a scenario when you would use a paired samples t-test. So let's do a scenario here. So let's say that we ask this question: does taking a study pill improve your test scores on some tests that you take, right? So let's say you have a scenario here. We have 4 students participating in this study, testing the effectiveness of a cognitive enhancement drug, and call it the magic study pill. So students take a test without taking a pill, and then they come back a week later and take the pill and take the test. And we want to know, does taking the pill improve their test scores? So let's take that general question and put it more technically. The research question will be phrased: is the test 1 average without the pill significantly lower than the test 2 average with the pill? Okay. Now, notice how it's phrased there, how the general question is asking, does the pill work? Well, how would you know the pill works? If when they took it without the pill, they got a lower average than the test than when they took it with the pill, okay? Now, you could also phrase it the other way. They got a higher test average with the pill than without the pill, but that would just change the order of the words. You would have to say, is the test 2 average with the pill significantly higher than the test 1 average without the pill, right? We would just flip the order of the 2 times there. So it could go either way, but my recommendation for us, and I'm going to repeat this when we get to the hypotheses, is whichever group is mentioned first in the question, in the general question, make that the first group mentioned in the research question, and then the first group mentioned in the hypotheses. That just keeps everything straight, keeps everybody on the same page, eliminates confusion, okay? So since test 1 in the general question, actually, the general question doesn't specify that, but test 1 comes before test 2, so we'll just make that one the first group. Okay, so is the test 1 average without the pill significantly lower than the test 2 average with the pill? Here's some characteristics here. One, we've got 2 groups, right? Or we've got 2 means that we're looking at here. That's the second one. We see specifying the difference. We have averages, which is means. We have 1 sample that's being examined, 1 group of 4 students. And we have the means of them from 2 different times. Now, why is our test 1 and test 2 groups related to each other? Because they're the same exact people, right? The same people who took test 1 are the same people who take test 2. They are related to each other because you are related to yourself, right? You're the same people. So that is why we would use a paired samples t-test, because we're studying the same group at 2 different times. So they are naturally going to be related to each other, those 2 groups, okay? So those are some characteristics of the paired samples t-test in the research question. Now, just like with the independent samples t-test, with a paired samples t-test, we have an independent and dependent variable. Independent variable is going to be our groups. Dependent variable is what we're going to be calculating, what we're going to be averaging up. Okay. So what is our groups here? What are our 2 different times, you might say? That would be taking the pill. Okay. So categorical, that's our 2 groups. So with the pill, without the pill. Okay. And that's our, our independent variable is taking the pill. Our measurement of that is without the pill or with the pill. Now we have test scores as our dependent variable. That's continuous because that's what we're averaging up. We are going to take an average for test 1 and average for test 2. Okay. So our test scores is what we are measuring, what we're counting up. And let's say the test ranges from 0 to 10. That's the average range. That's the range of the average you could get. Okay. So that's our variables. Now, how would we calculate our t-score? Now, the t-score means the same thing. It's calculated slightly differently, but the equation is set up very much the same way. The top part is the difference between the means. The bottom part is sampling error. Notice how here we have X bar and Y bar. It's a new variable or new symbol you're seeing there. Y bar is just indicating the same sample measured at a different time, right? X is sample 1, so to speak, even though there's not a 1 there, but the only sample we have is by default sample 1. So X bar is sample 1 at time X, time 1. Y bar is sample 1 at time Y, right? Or the time, the second time that it was measured. So we have the sample mean from the first time minus the sample mean from the second time. So X bar minus Y bar. Still, it's the difference between our means. It's the top part. The bottom part is sampling error. Now, the sampling error here is called the standard error of a difference within cases. This is very important because calculating the standard error when two groups are related, it's essential that you have the scores of each person in the sample paired with their same score in the second group, right? So the score of Jimmy in the first test needs to be compared to his score in test 2. But we need to make sure that we're pairing each person's scores from the two different times together, because we're comparing people within a group. We're not comparing two different groups between each other. We're comparing them within the same group, just measured at two different times. So in order to calculate the standard error of a difference within cases, you take the standard deviation of the different scores, which is this top part here, I'll talk about that in a second, over the square root of n, okay? Now, the standard deviation of the different scores is where you take the different scores for every person in the group in time 1 and time 2, and you're pretty much getting the average difference between the two times there. That's essentially what that standard deviation is calculating there for us. Now, the t-score represents the same thing like it did before. It's, as it always has, it's representing the difference between our two group means factoring in sampling error. With the paired samples t-test, it's specifically showing us the difference between two means from one sample, right? Two means gathered at two different times from the same sample. Now, let's put this all together and let's actually do some calculations with the paired samples t-test. So again, we have 4 students come in and they take a cognitive enhancement pill, magic study pill. They take the pill and take a test. And then then a week later, they take a test without taking the pill. I think that is a typo there because our original setup was they take the test without taking the pill, right? So I need to just fix that wording. They take the pill without taking the test. They take the test without the pill, and then a week later, they take the test with the pill, all right? So back to it. How do we do our calculation? Well, we need to find our mean for sample at time 1 and then our mean for our sample at time 2. The test 1 average is the test 2 average pretty much. And then we can calculate everything else we need to move forward, okay? So our sample means are 2 and then 3.75, okay? You can see that the test 2 average is already higher than test 1 average, but it could just be because of sampling error. It could be an acceptable difference, one that is likely to find, assuming there's no actual difference between the two tests, right? That's something we'll focus more on with the hypothesis testing. But just keep that in mind. You do see that test 2 is higher on average. Now, we can plug all the numbers that we have available here into the equation for the standard deviation of the different scores, and we get 0.50. We can plug that in for the standard deviation or standard error of the difference within cases. So 0.50 on top, it's taking the square root of the sample size on the bottom, 4, and we get 0.25 as a result. Go ahead and try to calculate the t-score now that you have the numbers required. Now, what you should have gotten is negative 7.000, or just negative 7, right? And the reason it's negative is because the sample y, right, or y bar is greater than x bar. So when you take the difference, you're going to get a negative number. So we got negative 7.000 as our t-score. Now remember that a bigger t-score indicates a bigger difference between the means. So with a paired samples t-test, the bigger the t-score, the bigger the difference between the two means from the one sample is. And so in the next video, we will talk about the paired samples t-test in regards to hypothesis testing.